2004, astronomers discovered something in deep space. First, it looked ordinary, just another asteroid drifting silently through the darkness. But then, they calculated its path, and what they found changed everything. There was a moment in time where this object might have hit Earth. Not a city, not a country, but the entire planet. They named it Apophis, and for a while, the world held its breath. But what really happened next is even more interesting. Apophis is a near-Earth asteroid, about 340 meters wide. To understand its size, imagine a giant skyscraper floating silently through space at thousands of kilometers per hour. But what makes Apophis interesting is not just its size. It is its path. It moves in an orbit that crosses Earth's neighborhood in space. And when scientists first studied its trajectory in 2004, they didn't just look at where it is. They looked at where it will be in the future. Because in space science, you don't just observe the present, you predict the future. And what they found required attention. Even a very small probability of impact means serious monitoring, not because danger is certain, but because the consequences are too large to ignore. So Apophis was added to the list of closely watched near-Earth objects, and the world of astronomy began tracking it continuously. As soon as early calculations were published, the story started spreading. First, only within scientific communities, but soon, media picked it up, and the message became simpler and more dramatic. A large asteroid might hit Earth, even though that wasn't the full scientific picture. Attention grew rapidly. People imagined worst-case scenarios: a city destroyed, a country affected, or worse, global consequences. The year 2029 became a focus point in early predictions, and that alone was enough to create fear in public discussion. But behind the scenes, scientists were not panicking. They were calculating. They were refining data, improving orbital models, and reducing uncertainty step by step. Because in astronomy, initial predictions are never final answers. They are just the beginning of understanding. And Apophis became one of the most studied objects in modern astronomy. As years passed, technology improved dramatically. More powerful telescopes, better radar systems, and more precise tracking methods. Each new observation added more accuracy to Apophis' predicted path. And slowly, the uncertainty started to shrink. What once looked concerning started to look far less dangerous. Scientists refined the calculations again and again, until a clear conclusion emerged. Apophis will not hit Earth in 2029. Not even close. In fact, its closest approach is now well understood and considered completely safe. It will pass Earth at a distance that is closer than some satellites, but still far enough to pose no threat at all. This was a major moment in planetary science, because it showed something important. The more we learn, the less we fear. But even after confirming safety, scientists didn't stop watching it, because space is dynamic. Gravity from planets, sunlight pressure, and long-term orbital changes can slightly alter trajectories over time. So Apophis remained an object of scientific interest, not as a danger, but as a natural laboratory. April 2029 is expected to be a historic moment. Apophis will pass extremely close to Earth, closer than many large space objects ever recorded in modern astronomy. For a short period, it may even become visible to the naked eye in certain regions of the world. A faint moving point of light, crossing the night sky. No explosion, no collision, no dramatic destruction, just a quiet cosmic event happening above us. But for scientists, this moment is extremely valuable, because when an asteroid passes this close, Earth's gravity can slightly affect its shape, spin, or surface. That means researchers will get a rare chance to study a real asteroid interaction up close. In real time, space missions may even observe it directly. turning apophis into a scientific opportunity rather than a concern. It becomes not a threat, but a visitor, a passing record of the early solar system, moving silently through space. The story of apophis is not just about one asteroid. It is about how humans respond to uncertainty. First, limited data created fear. Then better science replaced speculation with facts. And step by step, understanding replaced anxiety. This pattern is not unique to apophis. It happens every time we explore something unknown in the universe. We imagine risks until we measure reality. Apophis shows us that space is not just a place of danger, but a system that can be understood. It also shows the power of modern astronomy. Without advanced technology, early predictions would have stayed uncertain. But with continuous observation, we gained clarity, and clarity is what turns fear into knowledge. Apophis was never a destroyer. It was a reminder that the universe is understandable if we are willing to study it. So will apophis hit Earth? The answer remains simple: no, but its story will continue to be studied. Not because it is dangerous, but because it is meaningful. It represents how far science has come, and how much we can learn from objects drifting silently in space. The universe is not static. It moves, it evolves, surprises us, and sometimes comes very close, but not close enough.